it's not going to just take you roughly 1 hour. Okay, there's two things. I missed certain thing on the last part of the example, which is how we check that when we install that thing, the thing is going to be according to what we have calculated. That the first thing, and second thing is going to be on the project, how we're going to run the project, and because there's a bit of changes has to be done within. I talk about up to that. All right. I just first of all let's talk about the last bit of that I missed. It should be last. I did notice that I missed that thing. Okay, remember the example that we did, and this one going to be the when the pulley is going to move, we give tolerance, installation tolerance and take-up tolerance. Okay, when we do that, there's sometimes how do we know that? Because we did calculated this one, right? We did calculate this one. We have how that we know when we install the belt, the pulley, the distance, and so on. The belt will it will behave as according to what I have calculated. All right. Basically, to know that we're going to during static, there's no movement. We're going to determine the minimum static tension. This the one. In the formula A2, there's a minimum static tension. Roughly, certain book, in most of the book, they use the average of the slack tension on the slack side and the tight side average. But specifically for this, what I call it, for this catalog, 90% of the average of the tight, this is F1, this is going to F2. That the tension of the tight side and the slack side divided by 2, that average. Okay, this is the formulas. Okay, just follow the formulas and you know where to get this one. The W and V going to be velocities, with speed and so on. The V going to be from number 3, number 5, there's going to be the V here, this type C and so on. All right. Okay, that's going to be the value here going to be how to get the hold on. How to get the TT, the initial tension will be the formula up here, and there's a TT and the TS here. Tight side tension and slack side tension. Okay. Okay. What they did that when they install it, okay, you set all the what I call it, the belt, and you based on the value minimum static tension, we calculate whether the tension should reach this value. Okay. If it reach this with the calculated value here, for example, you calculate the value here, that means the belt system will behave as expected that we're going to be. For example, the power rated that we calculated here and so on. Hopefully, it will behave as we calculated in the the first until number 6 step. Okay, that's the thing I forgot to mention to you is how we going actually when the installation is done. Okay, we check the static tension belts to ensure that okay the belt should be set up. Okay, that meaning that when it's run, it will behave according to the one that we calculated in step 1 to step 5. Okay, that's the thing that we miss. Right, that is done. Any question on this one? I think that's just a matter of plug the number to the formulas. Any question? I think straightforward, right? Nothing much. All right. Okay, this is the second part of the class. The second part is going to be the project. Okay. Okay. I think today going to be our last class. Okay. And because next I have to perform enhash. Enhash next week. My flight will be on the 6th of June, which is next week. That means I have to stop the class here, and the major project and the minor project you have to submit to according to the e-learning, and you can ask me or Dr. Afandi Zakaria. Don't expect me to reply on the spot. Maybe the time zone different, and maybe I have something else to do. All right, but If I have time, I will reply, because there's two things here. There's three things that we need. Test 2, fine. Test 2 will be on week 15. However, there is maybe a bit changes on week 15. But then I think the last Tuesday or last Thursday on week 15, according to the schedule, that will be the same topic that you have. It's going to be the stress of the belt, bearing, and belt. That's done. That is just we have done the lecture. The second part will be the minor project, which is I give the lectures, that will self-study and the minor project, right? Okay, that will be the minor project to be submitted by 30th of June, right? And the major project 30th of June. Leaders of the group, use your e-learning to submit. I have, if you go to e-learning, there is a submission link. Make sure that group leaders, and for example, it's 3 of you, I think I assume the first name will be the group leader. That is my rule of thumb. Whoever for example, let's say 3 of you, let's say group 5, the first name in the list will be the group leader. Use the account to submit your works. All right. How do I? Okay, before we because I will give everything what we have to Dr. Fendi Zakaria, and okay before yes, only leaders will submit the project. Project as a group, both minor and major as a group. The minor project groups and the major project as group as well. All right. Okay, I just recall your, let go for major project first. Okay, just recall the major project. Okay, this is going to be the major project. I think I just go through what where is the major project. Okay, this is a project of hoisting device. That means the device have to lift the whatever weight. A team of 3 engineers, among you maybe 2 engineers, are assigned to design a power transmission for hoisting device. The hoisting device must be able to lift maximum load of 5,000 Newton, roughly 500 kg. Due to budget constraint, you have to make use of the following available parts. One motor, 1.2 kilowatt, because that is the available part, LS at 1000 RPM, power rated. The other motor will be 1 kilowatt, LS 1002 RPM. Rotating drum or the power rope, there's a existing rotating drum. The rope is 120 millimeter diameter. Okay, the following design constraint must be compliant. This is a constraint set by the companies. The maximum rotation speed of the ramp is going to be, cannot go more than 30 RPM. That means it can go lower than 30 RPM. Okay, the same thing here. It can lift maximum load of 5,000. Okay, that means that due to the safety factor, you can have more than that. That's the idea. That means if for example, let's say you design that thing, after you have that thing done, you can end up with 6,000. That's fine. That means you give another 20% extra for safety factor. Right? It should be higher than this. That means on the other, this one is going to be different. Okay, on the 30,000 30 RPM. That means if your design, if you do the transmission, at the end of the day you got 25. That's good. And don't make sure that at the end of the day your initial design come up with 40. There's something wrong with your design, because you want the maximum speed of drum going to be 30. Okay, maximum gear ratio per pack is going to be 10. Okay, a report must be submitted by 30th of June of 2020. That is the last Saturday of the week. Okay, the report must consist of design of overall geometrical properties, all engineering analysis of the machine component and engineering drawing. It's not engineering drawing. It's mostly on schematic drawing. Don't make engineering. It's mostly on the schematic. Just schematic. I just correct this one. I don't want you to make a really schematic drawing of the gearbox. Machine component involve a bearing, gear, belt, shaft, and shaft related component. Okay, condition. Okay, as you know that on the gear stresses, you have to iterate. For example, you start with certain module or certain piece diameter. Okay, the iteration, the first analysis has to be done manual. That means manual calculation. Let's say you start with module 2, Okay, you check the interference. After that, you check the bending stress against fatigue. Then you check the surface stress against fatigue surface. Okay, whether doesn't matter it's going to be failed at the end. That's fine, not to worry. Okay, three of you. Okay, if for example there's two pairs, that means one pair will one person will do the largest one, the fastest one. The other two person maybe choose one. The other person with the medium one, the lowest one, or the other one will use maybe one of them. But you can iterate with the initial iteration with different module. That's the way to work. Then after that, maybe your calculation is failed. That means your you done is A student, your team member one fails, team member two, the result going to be both. Maybe the bending okay, but the surface it failed. Maybe the team member C going to be okay, not to worry. Then you develop the one system that using other method, MathSCAD or Excel or even programming using what you have learned. C to iterate the process. That means you input all. Remember the three pairs. The three pairs, you get the final module. That means using that system, the iteration system, everything should be passed. That is there's no interference. There will be the bending stress is fine. The surface is fine. Okay, in our lecture, I did mention that in order for bending stress to be fine, roughly the surface should have the fatigue factor of 1.2 to 1.5. Right, and that is the rough estimation. Okay, state or assumption made in an analysis. For example, let's say this you have to think. For example, let's say what's going to happen if you lifting a load. Alright. What going to happen? Is it going to be very impact or is it going to be very net? Also, we have to. Is it the output is going to be what call it? No shock, no impact or whatever. You have to make assumption there. Because there's no assumption here. Because remember, you are designing the thing, then you have to make an assumption here. You have to state the assumption. Okay, initial not to worry, you can submit to the project at the end of the day, 31st of May, that will be the submit to report. Okay, report. There's two part of the reports. The first part report going to be a report. That means what I mean reports is the written part. And the second part will be engineering analysis with appendices. In the appendices, okay, it can be handwritten, but must be very, very nice handwritten, must be legible. It can be, for example, let's say, it's very nice to read and so on. Okay, that is very, very nice. Every analysis should allow in the appendix. Okay, okay. In the report here, for example, only the final selection will be should be in the report. In the report, you shouldn't talk about how to do analysis. You shouldn't talk about how to do analysis. You should talk about only the final one. If the person interested to see the calculation, he will refer to the appendices. Even in your PSM, if I were your supervisor, I would prefer to have all the analysis will be at the back. And the report just state the result from the analysis. That's very good. Otherwise, go add to the appendix. Okay. 1.0 introduction into the report, I think is maybe a simple quarter pages to half pages. Okay, I just mentioned this one, maybe half pages. A small half pages to half page. Okay, that's what is going to be the report and so on. Problem statement, state the problem and scope. Result. Then you start to give result. Imagine the motor selection and the final RPM output. The schematic drawing, you should done that one of the result. Because you have selected motor, you can either select motor one or two motors or maybe combination of two motors. After that, what you should do, you do the forward what you call it, forward calculation analysis, find out what is the final output. That for example, one motor here, you take this motor here. So you select this one. Okay, with each pair going to be loss of 0.90% for gear. Okay, then you proceed the analysis. Then you will get the final output. What is the RPM output based on the ratio gear and so on. That will be here, motor selection. And the final RPM and power output at the end. Alright, gear. Okay, this is the gear. You just state the final module of the for the gearbox. Let's say the faster will be module 3. The a bit slower, maybe you can use it. It happen a bit higher or lower one. It depends. Okay, then you state the maybe there is a bit different between the faster and lower one. Okay, because as you go, as the getting slower, the torque getting higher because you're transferring the tau omega, right? The power going to be the same. As the omega getting slower, the torque getting higher, meaning that I expect that the lower gear going to be higher module, or for module, or for the pitch lower pitch diameter pitch, because lower diameter pitch is going to be larger tooth. Bearing, okay, state the final section of bearing, discuss the characteristic of the bearing, because the bearings there is going to be maybe possible for. Then I mentioned to you that the bearing you need to one of the lower the one that have lower radial load times 7 for the thrust load. That the thing they have. Okay, there possible one side will be have 3 possible solution, 6 possible solution. Maybe for the with the thrust load, and the other one will be 9 possible load. Okay, state the final configuration of the just state fiber diameter pulley is going to be, for example, like the one you have done before. Diameter D1, larger pulley, center to center distance, let's say C95, number of bearings 5. Okay, that it will be different case for each one of you. Shaft, okay, diameter of the faster, because there's 3 shafts. I think if you have 2 pairs and a minimum of 3 shafts, if you're more than 3 shafts, just choose 3 shafts. Okay, not to worry. Then you state the diameter of the fastest, lowest, and moderate, and discard the result. Okay, based on the 3 selected, this one shaft bearing, then you have to iterate what is the final dimension for the shaft and what is the final dimension for the bearing, because there are possible 9 possible solution. Maybe you choose one solution. If, for example, in the case of there is certain case that the solution the calculated is too high. The calculated maybe the radial load is too high. It is possible because of the bearing you cannot select, and maybe the bearing going to be very large. As getting get larger bore, the diameter bearing get very large. Not to worry. Okay, you can discard that the reason because of we are limited to 3 type of bearings. Okay, in real life you have so many type of bearing, meaning that we can choose not just 3. Okay, within 3 there are so many classes, right? And you have more selection instead of the one you have now. Because of that, maybe the answer a bit ridiculous in this case. For the bearing and the shaft, maybe you have to make a very large bearing and very large shaft, bore diameter shaft, because of the limited size. Not to worry. All right. Discussion, state the final size of the gearbox and discuss the method to reduce the gearbox. One of them. Why there is reduce the gearbox? The design is very. For example, gear is limited to only spur gear. That causes you a bit of problem. Even the bearing is limited to 3 types. The belt is limited to V belt. There's so many limitations here that cause you that cause the gearbox to be very, very large. Sometimes very large. All right. That will be the report and the result, and finally appendix. Appendix, there's 2 parts here. The first part going to be the individual works. Okay, it's going to be the first part here, the motor selection and this one, engineering analysis of the gearbox from input to output. The gear, your schematic drawing that you have done this, drawing to show the final size of the gearbox, and that will be the final one. That will as a group, and this considered as a group work, and this will be as a group work, and this considered as a group work. Okay. And the other one will be individual analysis. That means state the member name first for each analysis. Let's say team member 1, gear analysis, bearing, belt, shaft, and team number 2, gear, and so on, team number 3, and so on. If you have 2 members, only expect to have 2 analysis. Okay, that's about the report, meaning that the appendixes actually is, if you do the analysis properly, you just insert the report, the analysis to the report. No need to types, no need to just handwritten. That is fine. And finally, you need to have the sample of traction system that you develop. Okay, any question on the how to write a report? Any question on this one? Okay, maybe you don't have any idea now because you don't focus on writing the report. You don't focus on writing the report. But as you have a problem, you can either WhatsApp me or WhatsApp Cik Fandi. Okay, I try my best to answer your question. Right? Right. That's the first one. Okay. The second one will be how to handle the project. I will. Okay. Let's say you have this one. I give. This is going to be the way to handle the project. Well, how to start first and so on. Okay. I will upload to the class. How to handle the project. Okay. I think. Okay. Number first has been done. I think you have done this. Right. Design the schematic drawing on the gearbox. Focus on gear ratio. Because okay, that's the first part. Then you do the second part of some of you maybe have done this, some of you have not. Gear analysis, manual, proceed with analysis, even though both of bending and surface fail, you still have to choose different gear pair. If you choose the same gear pair, start with a different module. Check the interference, the bending and the surface. Not to worry, if it's bending is failed, just proceed the analysis. No need to worry because then after that develop the traction system for the gear analysis. Number 4 going to be use the traction system to determine the suitable module or diameter pitch of the gear that will make sure both bending and surface stress safe. Meaning that in my lecture it did mention to you roughly going to be 1.2 to 1.5 for the surface stress, and the bending going to be roughly 6. All right, if you get the value, for example, bending going to be bending to be failed and surface fine, there's something wrong because it should be the bending is most critical. Okay, roughly going to be 6 and above, and that meant the surface stress going to be 1.2, 1.5. It might be different. After that, remember the bearing. After you get the gear, you can do the bearing. Then after you get the gear, you can do the because you have the phase width. The phase width is going to be between 4M to 9M, right? Then you have to in between. You have the phase width. You know the phase width of the gear. You can set the you can start design the shaft where to put the bearing and so on. You can set the diameter between the gears and between the gears and between the gear and the shaft. If you want to have overhang mounting, there will be a problem because there will be overhang problem, overhang in between. Remember the overhang, the shaft you put in between, that will be the critical part. Maybe the critical largest diameter will be at the bearing, or you can have at the like a cantilever type of not cantilever, a simple supported shaft. That means you have both at the end. It's up to you. Then when you have designed that roughly the shaft, then you start do a bearing analysis. Okay. At this time, remember that I mentioned to you that for the smaller, because after you have the shaft here, you can start doing the free body diagram. Is it right? Because you have the gear, you have the shaft, all the dimension, the dimension, what is the length between the gear 1 and what the length between gear 1, gear 2, what the length between the bearing, gear 2 to another bearing. You have to set that. Okay, the basic rule is that try to make the length as short as possible. Why? When you make the very long shaft, the bending going to be very, very big. And the bending very, very big, your shaft going to be larger, and your when the shaft get larger, and that will cost you on the bearing as well. Make it smaller when the shaft, when the shaft very big, and it costs you for body to be larger as well. Because imagine you have two feet to support. If you're smaller one, it's very difficult to deflect, right? If you have very long one, the shaft going to be very easy to deflect. Okay, that's up to you. You have to do a bit of adjustment here. To me, I advise you to have very short, for example, let's say shaft. And let's say between the bearing, maybe let's say 50 millimeter, don't try 150 and so on. Okay, you can use all the dimension from the shaft, right? For example, like this one in the shaft here, right? The radius of the fillets and so on here. This is going to be your initial the bearing. This is a bearing. Bearing. You get this after you do bearings. Okay. Then you can all the shaft. This is going to be your first shaft, because shaft, if for example, if you run the diameter, it's going to be iteration process as well. You're right. Because remember, iteration process shaft is a d cube, right? Because md cube, all right? I think with the new calculator, you can iterate very fast. That's fine. Okay, because remember the let's say bending is going to be 32 mc 32 m divided by d cube. All right, it's going to be iteration process. Because of imagine the kf going to be relied on diameter and so on. There's so the iteration process it goes on. If you change diameter, the kf the fatigue and the inner limit going to be different. Imagine that the kind of thing that you have to iterate. Because of that, you can use the value of ds as your initial guess from the bearing. Otherwise, it's going to be very, very, use the as initial bearing, check whether it pass or fail. All right. Then you fail, you make it larger. It's passed, that's fine. That's good. Right? Okay, that will be do the bearing analysis on the selected shaft. Each member, based on the selected bearing, refer the proposed shaft ds as initial diameter of shaft using the fatigue analysis to ensure the shaft will have the final life. That will be the relation between bearing and shaft. They're very important. Okay, with these two, the bearing and the shaft, you can finalize the selection of the bearing selection and diameter of the shaft. For example, let's say I did give you a note on this one. For example, let's say you have diameter of shaft of 10, 20, but the bearing is 30. What are you going to do? If you reduce the bearing by 30, by 20, the bearing will fail. That means the only way is to make the bearing by 30 millimeter. That's the way to work. They have to finalize the bearing selection and diameter of the shaft by treating the bearing and with the diameter shaft. You have to make sure both are failed. The other, because of the selection, is going to be a number, maybe 9. Then you have to choose which one going to be the one that you want to choose. All right, and finally, this analysis is going to be a bit independent, because the bearing, the reason is that why I start with gear, they are entering this one, with gear, because the gear will have the tangential force and Fr. Okay, that will start you, that will lead you to have your initial geometrical properties of the shaft, where you have to put the bearings, what is the load, and you can predict the radial load and the thrust. Radial load, because the spur gear that have only one, there's no thrust load, right? However, I did mention to you, you need to assume the smaller the smaller radial load with 7 thrust load. Otherwise, that you always have 9 possible solutions. You don't training In the case of having transfer in the exam, what's going to happen? All right. Okay. You add another one for 7 times. You do 7 times. Double check my slide. 7 times. Then you do that bearing, and from the bearing you go for the shaft. You see the flow here. This is going to be the flow. Right. This is going to be the flow. How you to do. Otherwise, going to be the selection of diameter of shaft going to be iteration process. Why? If you change, it's D cube. Remember, D cube, if you change the diameter, you need to change the CG, right? CG, geometry or the fatigue life. This is iteration process. At least when the very proper give you at least the DS, you can start with that iteration. Then you can add another 10 millimeter or whatever. It's up to you. All right. What else? Okay, then this is going to be independent, not to worry. All right. The bearing, because you are replacing the first pair of gear with belt, and then you choose the first person with minimum center to the distance with 80 inches, the second person with center to 23. Maximum, this is maximum, and the person minimum of 20 inches. If two of you, just do the first two. Okay. Any question on this one? I stop you here. Any question? I will give this thing to the WhatsApp group. Any question? At leaders, make sure you understand because you're going to guide your team member. Any question? All right. All right. That will be the. All right. Then the step for gearbox. I think this I have give you the for the submit gearbox. Because some of you I see, some of you just assume to output, two motors and whatever. Some of you just do the analysis straightforward. The first step of design gearbox that you just focus on gear ratio. No need to focus on what is the module, what is the fault. You don't do the second step. Okay? Okay, as for the schematic box, gearbox is concerned, no need to worry about free body diagram first and module. Okay? Just focus on the ratio. All right? The free body diagram and module will be taken into account while doing the analysis. It's true, on the second stage here. This is going to be the finalist of the, that's why we do the analysis second. Then we get all the FTFR, then we can proceed with shaft. That's the reason this is a procedure. Very important. If you do independent, you start with shaft, then the iteration process is going to be, it's okay, you can do that, but it's going to be, the iteration process is going to be longer, right? The free body module taken came during the analysis stuff. When you finalize the modules, then the free body will be, you can start do the free body diagram. Okay. Step to determine the gear ratio of the gearbox. Okay. Calculate the power. Okay. Remember the power going to be 5 Newton using 120 millimeter diameter drums at LS3 at 3 RPM. Okay, that will be, I think, 0.942 is not mistaken, watt, kilowatt. Okay, then you start to think, okay, I want to reduce, you have 942. Okay, let's say I want to reduce by 2, let's say by 2 reduction. Okay, then you choose which motor or which motor you want to choose, this one, sorry. Which motor you want to choose, okay, or you want to use both motors, it's up to you. Right, if you've done that, then based on step 1, select the right motors and then start design the box. Then you have the ratios and so on. Then step 3, you have the input motors, you have the ratio, and you forward the calculation, and you can finalize what is the load. You can find what is the load and what is the speed. It should be speed lower than 300 RPM, 30 RPM, and the load should be larger than 5,000. It can be larger because it's going to be roughly the safety factor. I think that's about it on the major project. Okay, let me, before I stop, I want to open minor project first. All right. Any question on major project? Hold on, I just go to discount on minor project. I'm looking for the way I put my minor project information. All right. All right. Any question? Okay, right? Okay, I think because you haven't start, maybe after you start you have problem, you can WhatsApp us, You can WhatsApp me or you can WhatsApp Dr. Effendi Zakaria. I will already add him and then I will state his number, You can WhatsApp both of us. Okay? Right. Now we go for minor project. Minor project, Okay, the minor project is to be bolts and welding. Actually, I just want you, actually, it's actually to based on your engineering judgment, Okay. For example, that bolt and welding, I give you a lecture in the my Google Drive, right? There is a lecture and the slide in the learning. Okay, it both together, Right, and a few example. That I think self-learning, Right. For the bowl, coupling is used to transmit power from one shaft to another. If you know coupling, for example, let's say you always think static couple. Actually, it's a coupling. Actually, for example, you have motors, you have a shaft. What is in between? It's going to be coupling. There are various types of coupling, which among them are flank, mouth, jaw, and fluid. Flank and mouth coupling is shown in these figures. Figure using both to transfer the power. Okay, let's say the simplest coupling going to be you make two cylindrical type of pole and you bolt it together. That's the simplest flank coupling. All right. Okay. Two shaft is a okay. What you do now is that therefore you have to calculate the maximum torque to be transferred between two shafts based on the similar design parameter. The important parameter that must be the same between both coupling. For example, let's say coupling and muff. Muff will be different. If you look at the muff, if you look at this going to be what going to take this one? This going to take shear load. It's a V. For example, like in this case, the load here going to be totally shear load. This one totally tension load. If you look at how it was worked, okay. If land coupling, that means the load will cut. Let's say let me have the pen here. This is going to be the bowl. You cut like this. That is flank. For the muff coupling, going to be pull like this. There's a lot different. Okay. Then you base on the same parameter. For example, similar bolt with the same number of bolts. For example, I choose 3 bolts M10. That means you have to use 3 bolt M10 here, 3 bolt M10 here. All right. And for example, both coupling using the M10, for example M10, the bolt are positioned at the same pitch diameter. That means the same diameter. For example, let's say the same pitch diameter. For example, you have 5 diameter of, let's say, 50 millimeters. This is going to be 50 millimeters. All right. Okay, in the case of the flank coupling, the pitch diameter is the distance between the center here to the center of the boat. That the radius, I think we should diameter going to be the center radius of the center of the flank, center of the boat. That to be radius of the pitch. And this one going to be center of the cylinder to roughly to the center of the axis, cylindrical axis. Roughly there. It should be the same. Okay, same design parameters. Okay, for example, you start with safety factor of 2, okay, and so on. Okay, finally, what is the safety? Maybe what is the load? Maybe find out that if I just give a clue here. Okay, if based on my judgment, right? I I I I I think I might be wrong. MAF coupling will have a larger load because it is in tension. Right, that is my judgment based on the configuration. Okay, I might be wrong. Okay, okay, you prove it. Okay, you just do the analysis here, find out. Okay, MAF coupling. I don't know. Maybe I'm wrong. Okay, based on this because I don't know what is the result, but I think this is going to be higher because you take one bolt can in tension it can carry one load, one car load. The one intention is very, very high compared to the thing intake here. I expect this one. You can correct me if I'm wrong. I expect based on my judgment. Okay. State your final judgment why you support the above question. Hopefully my judgment is right. Okay. I think MAF, according to my judgment, MAF coupling will higher load F compared to this one. Okay, maybe I'm wrong, not to worry. Okay, the same thing goes to here, right? Having the position of very strict important decision to make a decision based on load applied into the welding. In this view, two brackets are welded differently as shown in figure 2A. Both brackets apply the same, the same parameters. Okay, the same welded side, the same welded electrode. Okay, what is the load P? Okay, then you use judgment. Apply with what is the important here. Let's say this one will have moment. That means I will be the factor here. Okay, which I is larger? Is it the first one or B? If I is larger at A, expected B going to be large. That is my judgment. Okay, but you have to do your analysis on that. Prove that judgment. That's all about the assume both bracket are welded and same slag size with the same electrode under the same design parameters. Calculate the maximum P of each bracket. Based on the above calculation, your investment. Is it possible to be? Is it possible you have to, for example, let's say, okay, if I'm this way, I would prefer in, let's say, 2A instead of 2B because 2A have, let's say, larger I, for example. Is it possible to use that judgment? Okay, that's about the minor project. Okay, actually, you have to use a judgment. Maybe my judgment is wrong. Don't take my judgment because maybe I'm wrong. All right, any question on the major and minor project? It's either one, there's no question, either you understand or you don't understand or it's either both ways. Hopefully you are on the fully understood. You fully what I'm saying. Okay, not to worry. If I have problem, okay. I think there's how many weeks left? 2 or 3 weeks. Okay, there's no more class. Proceed with your be disciplined. Proceed with the project, major, minor. You do major project at the same time you are revising your test too. Okay, because it's going to be the same thing. Okay, the test two, I think Dr. Penny will remind you when will final date for the test two to the WhatsApp group. I will put the how to handle in the WhatsApp group as well Dr. Effendi phone number if you want. You can WhatsApp me, but I cannot promise you I can. Maybe I have so many other things to do. Okay, but hopefully I will because okay, right. Any more question on the major and minor project? You have left major 30%, test two 30%, maybe 60%. that only based on 3 topics. Test 2, you do the major project, you are revising for the test 2. Focus on that thing. Minor project, that's the reason why, because be independent study, the only 2.5%. Is it 2.5? 5%, sorry. 5%, 2.5 for the book, 5%. That is a 65% at the end of 30th of June.
Doctor, sorry for interrupting. Test 1 and test 2 covers 60%.
Test 2, 30%, major project, test 30%. Basically, the test 2 and major project are 60% because they are covering the 2 same topics. They are covering the belt, the bearing, and the gear. That
And
means
test 1?
test 1, 30%. 30 test 1, 30 test 2, 30% major project, 10% assignment, which is
And
5% from the previous that I give you, the e-learning thing, 5% from the bolt and welding, 2.5, 2.5.
Okay.
Make sure, I think the importance of major project, because when you do a good major project, it will help you for the test 2, it will help you for the, maybe for those who got maybe a big problem with test 1, okay, maybe will help you. There's 2 things, major project will help you a lot.
Okay.
Okay, have major project will help, but you have to put effort on it. Don't try, okay, I will do nothing, I you got higher mark. No, you won't
Yeah,
do.
of course.
Okay?
Doctor, I'm sorry, but for assignments and quizzes, for those, who couldn't do it on time, is there any possibility?
Amar, is it? Amar,
Yeah.
if you do that thing, it's already passed. Focus. You have now 7
Yeah, but
weeks.
we are talking. Yeah, but we are talking about 10%. It's not. It's not.
Yeah. Focus the right thing first. With the higher marks.
All
That means
right.
the time you spend, maybe the same with the 60%. It's no point to cover that thing. Look forward. Okay?
All right.
You have
Thank you.
60% in front of you. You have 65% in front of you now.
All right.
Focus on
Thank
that
you.
thing. All
Thank
right?
you so
Thank
much.
you.
All
All
right.
right, that's the way to work. If you look at the thing, I think you are trying to solving the 5%. At the end of the day, it will affect your 60%. Okay?
All right.
You see my point? That's
Yeah,
why
I just so if the 60% already in my bucket, then I can move to the 10%.
but are you sure you're going to get 60%? Just focus, even, okay, right?
All right. Thank you.
Okay, just focus on 60%. Okay, try to get as high as possible. I want to tell you this, that major project will help you a lot. Okay, major project will help you a lot. Do the major project. I think I give the guide. You just follow the guide. It's compared to test 1 and test 2. Test 2 is a lot easy. And not to be easier to score, okay, right? But if you, from your experience from the exercise that I give you, it's going to be like a procedure, right? Belt is just a procedure. 1, 2, 3, 4, 5. Bearing 1, 2, 3, 4, 5. That's it. Except for bearing, going to be free body diagram. Except for gear, free body diagram as well. But the free body for gear going to rely on the FT that you learn on the topic gear force. Okay, focus on major project that will help you on minor project. Okay, don't try to cheat around. Okay, I can take that the team works. Okay, nobody. Okay, you may survive your major project, but it will not help you in the test 2. Okay, just be honest. Okay, just be.
So the major project will help me in test 2.
Yes.
Okay.
If you do properly on your own, that will help you. All right.
Okay.
Right. Any more question? Okay. Hopefully, I'm sorry. There's something coming up. I cannot finish the class until the end. All right. Dr. Fendi will take over the class. Actually, even I take over the class, there will be no more lectures. Okay, the same good. Except that I will supervise you the major and minor project as well. The test 2 will be taken online. That's it. Okay. If you have problem with the major and minor project, just WhatsApp us. I mean us, both of us. But if I have time, I will reply for you because this I feel about that the part of my responsibility to answer it to you. Okay?
Okay. So today, just to get this straight, so today it's the last class.
The
No
last
more
class.
class
No more
anymore.
class after this. Yes.
All right. All
That
right.
means
Thank
you
you.
have to be on your own, to be focused on your own, to work independent on the major project, minor project. All right?
Okay. Thank you so much for your effort, Doctor.
Okay,
We
right.
appreciate it. Thank you.
All right. Okay. Any more question before we end? Okay. Focus on major project. We have your test 2, that's 60%. That is my advice for you. Be honest to yourself. Cannot to then we'll help you. That is okay. You can cheat on major project by having other group. You take from other group and do that. Oh, not to worry. Okay, but it will defeat the purpose. Because this 30% will come from the test 2. All right. I'm going to end today. Okay, already 1 hour. All right. No more question. Okay. If you have question, maybe you don't have question because you haven't proceed with the analysis. Okay, don't delay your analysis. Okay, just make yourself routine during the 5 hours lectures. Okay, make yourself do something on component design. I think that will be at least will help you to proceed with the major project. Okay, just be self-disciplined. All right, thank you very much. Assalamualaikum. Stay safe and okay.
Wassalam. Thank you, Doctor.
Okay, thank you. I'm sorry for everything because I should finish the class to the end. I cannot. Okay, I'm sorry. Okay. Assalamualaikum. Stay safe and goodbye.
Doctor.
Okay, right. Go ahead.